Okay, let's go through these solutions for arithmetic progress quiz number 2. So this is just testing our ability to do addition, not in our heads, even though you probably could do this in your head, but we do want to practice using the addition on paper rules that we studied. So we're going to do 11.2. Remember to line up the decimal points whenever we're doing addition. So 5.6. And then if you go to the first column, 2 plus 6 is 8. Remember to bring down the decimal point. 1 plus 5 is 6. And then 1 plus 0, imagine there's a 0 right there. And we get 16.8. So that is the correct answer to number 1. Okay, let's go ahead and move on to number 2. So this one says, for which columns would we put a 1 on top to indicate a carryover? So that's whenever you add the column together and it's 10 or greater. That's the carryover. So 2 plus 7 is 9, so no carryover there. 0 plus 1 is 1, no carryover there. 3 plus 4 is 7, no carryover there. However, 2 plus 9 equals 11. So what we have to do is put a 1 right there and then put a 1 right there. And then, of course, 1 plus 1 plus 3 is 5, so there's no carryover. And so what we get is the carryover is going to be on top, because if on top, which column? It's on the leftmost column. So the correct answer is A. Question number 3. So this is testing our ability to do subtraction on paper. So what we want to do is put the number 1234 on top. So 1234. And then we're going to put the minus sign right there, and then 5, 6, 7. Remember to line up the decimal places, which we are doing, because there's a decimal place after the 4 and the 7. So 4 minus 7, we can't do that, because it'll result in a negative number. So we have to borrow from the 3. So we're going to turn the 3 into a 2. That allows us to put a 1 right there. And so what we get is 14 minus 7, which is 7. 2 minus 6, we can't do that, so we have to borrow from this 2, make that into a 1, and this becomes a 12. 12 minus 6 is 6. 1 minus 5, we can't do that, so we have to borrow from here, put it into a 0, make that into an 11. 11 minus 5 is 6, and so the correct answer is 667. So that's how you subtract for that one. Question number 4, again, we're doing subtraction. You want to line up the decimal places, which is not going to be as straightforward in this case. So we put 7.72 as the top number. And remember, we want to line up those decimal places. So we're going to put the 5 right there, the 9, the 6, and then the 1, 1. And then we're going to put a 0 and a 0 there to make all of the math work. So we can't do 0 minus 1 or 0 minus 1. So what we have to do is we have to borrow from the 2. Turn that into a 1, turn this into a 10, and then immediately borrow from that, turn it into a 9, and this becomes a 10. So 10 minus 1 is 9, 9 minus 1 is 8. 1 minus 6, we can't do that, so we have to borrow from the 6, turn that from the 7, turn it into a 6. So this becomes 11 minus 6, which is 5. Can't do 6 minus 9, so we need to borrow from that, turn it into a 6. This becomes 16 minus 9, which is going to be 7. Don't forget to bring down the decimal place, and 6 minus 5 is 1. So the correct answer is going to be 1.7589. Question number 5. This is probably the trickiest question, but it's good that we are introducing these data sufficiency questions, at least in some form, to you pretty early, because remember, this is a pretty big chunk of the data insights section. These data sufficiency questions, they can be anywhere from like 5 to 8 out of the 20 questions. So here we go. The way this works is, first of all, look at the given information. The given information is here. So we have 1p either minus or plus q, and it adds up or subtracts to rs, which is a 2-digit number. And the question is, did the student add? And we have to determine, do we have enough information here to determine whether the student added or subtracted? Like, how do we know? So let's imagine that we're looking only at information number 2. So it says p plus q is greater than 10. So I can do, for example, 19 plus 3, or I can't do that because R and S have to be distinct digits, and that would result in 22, which is not distinct. So I could do, for example, plus 4, And what do I get? I get 23. But at the same time, I could also do 19 minus 4 and get 15. In both cases, I have a 2-digit number, 23 and 15. In both cases, 9 and 4 add up to greater than 10 in both cases, but I don't know if I subtracted or added. So that's not enough information. So that allows us to eliminate B and D. So the next thing is we want to go to number 1 and look at only this information by itself. So it says S is less than the smaller of P and Q. So we've already created an example here. So 19 plus 4. Notice how S is smaller than those. Can we create an example where that's true even when we're subtracting? So that's kind of the question. So let's take a look. So what if we were to do 19 minus 5? And we would get 14. So this is S. That's still smaller. So again, this is not enough information. So we have to cross that out. So this is when we have to combine the two pieces of information. We have to combine the two pieces of information. And let's actually think about this for a second. So I'm going to pause the video and think about this myself. Okay, so here we go. If we were to combine both of these pieces of information, is it enough? Well, what if we were to do 19 plus 5 and we get 24? And let's do 19 minus 5 and we get 14. So are we satisfying? So S is smaller in both cases. 4 is smaller than 5 and 9. 4 is smaller than 5 and 9. And in both cases, P plus Q is greater than 10. 9 plus 4 is 14. 9 plus 5 is 14. 9 plus 5 is 14. So no, this is not enough information. So the correct answer has to be E. Ooh, that's a pretty tricky one, huh? All right, let's go ahead and move on to number 6. So this is when we're practicing our multiplying on paper. So remember, when we do this, it's not important to line up the decimal places, although that sometimes does happen. So what you want to do is just have the rightmost digit lined up with the rightmost digit. So we're going to have 82 times 24. Put a little line there. If you want to put an X there, go for it. 4 times 2 is 8. 4 times 8 is 32. And then remember, when you go to the next digit to the left, you have to put a 0 there. 2 times 2 is 4. 2 times 8 is 16. And then it becomes an addition problem. So 8, 6, 9, 1. 1968. What a great year that was. Actually, that was a bad year. I read a book about the tumultuous 1968. You know, you had a lot of assassinations and there was just a lot of political turmoil. And then that was the year that the astronauts didn't land on the moon, but went around the moon. And it was like around Christmas time. And it was like it rejuvenated the country during a time of great political turmoil. All right, let's move on to number 7. So this is going to be a pain in the butt, but you know, it's good to practice. So we have to do 56.115. And then remember, you want to line up the digits to the right. So 322, 22. Okay, yeah, this is going to be pretty annoying, but that's okay. All right, here we go. 5 times 5 is 25, so we put a 5 there and the 2 there. 5 times 1 is 5, plus 2 is 7. 5 times 1 is just 5. 5 times 6 is 30, so we put a 0 and then a 3. 5 times 5 is 25, plus 3 is 28. All right, and then just to keep things nice and organized, let's get rid of those as we go to the next level. All right, don't forget to put a 0. 3 times 5 is 15, so put a 5 and then a 1. 3 times 1 is 3, plus 1 is 4. 3 times 1 is 3. 3 times 6 is 18, put the 8 there and the 1 there. 3 times 5 is 15, plus the 1 is 16. And then again, don't forget those 2 zeros as we go to the next level. I'm also going to erase those just so they don't get confusing. 2 times 5 is 10, so put a 0 and then put the 1. 2 times 1 plus 1 is 3. And then 2 times 1 is just 2. 2 times 6 is 12. Put the 2, carry the 1. 2 times 5 is 10 plus 1, which is 11. And now we're doing 3 zeros. 1, 2, 3. Remember, this third 0 came from the 2 times 5, right? Let's go ahead and erase that and that. And here we go. 2 times 5 is 10. That's 0. 2 times 1 plus 1, that's 3. That's going to be 2. We're basically doing the same thing because it's 2, 2, right? 2 times 6 is 12, but carry the 1, and this is going to be an 11. Whew! And now it's an adding problem. All right, so this is 5. This is 12, carry the 1. So that's going to be 5 plus 5, which is 10. So 0, carry the 1. 3 plus 1 is 7. No carrying. 16 plus 5 is 21. So put the 1, carry the 2. So we have 2 plus 2, which is 4, plus 6, which is 10, plus 2 more 2s, which is 14. So put a 4, carry the 1. That's going to be 5, because 1 plus 1 plus 1 plus 2. And then that is going to be 2. And that is going to be 1. And then finally, we have to count the number of decimal places. So 3 to the right, 1 to the right. So that's a total of 4. 1, 2, 3, 4. So 12,541.7025. Let me actually confirm that. Hold on. Surprisingly, I did it. That was the correct answer. Wow. I know, that was a pain in the butt. I don't think you're going to have to do anything that tedious on the real GMAT. Okay, moving on. So this one says 2 numbers are multiplied together. The first number is a 4-digit integer. The second number has 1 digit to the left of the decimal point and 3 digits to the right. And what they're asking us to do is the maximum number of digits. So one thing you can do here is, first of all, ask yourself, how do you make a number as large as possible? Use 9s, right? So for example, let's imagine the first number has 1 digit, so 9. And the second number has just 1 digit, also 9. If we multiply those together, we get 81. So notice 1 digit, 1 digit, and then we got a total of 2 digits. Okay, what happens when we do 99 times 99? So 9 times 9 is 81, so put the 1 there and then the 8. 9 times 9 is 81 plus 8, which is going to be 89. Then we put a 0. 9 times 9 is 81. Again, carry the 8. And then this is also going to be 89. So what we get is 1. And then that's 10. So you have to put a 0 there plus the 1. So that's going to be 18. 9 plus 9, because there's a 1 there. And that's going to be 18. And then carry the 1 and you get 9. So 9801. So again, 2 digits, 2 digits, 4 digits. So it seems like we're just adding the digits together. So if the first number is 4 digits and the next number has 1 digit to the left and 3 digits to the right, that's also 4 digits. So 4 digits times 4 digits, everything is 9. The result is going to be 8 digits, 4 plus 4. And you'll notice that the decimal place doesn't matter. Like, I'll give you an example. So if we do 9 times 0.9, like that, this is going to equal 8.1. And notice you still have 2 digits. So this is 1 digit, this is 1 digit. You still get 2 there. So the decimal point doesn't influence this or change it. So the correct answer is just 4 plus 4, which is 8. Number 9, now we're practicing our division on paper. So what we want to do is put 1072, and then we put the house on top of it. And we put 16. Okay, does 16 go into 1? No. Does it go into 10? No. Does it go into 107? Yes. How many times? It's going to be 6 times, because 6 times 16 is 96. And then what's the difference? That's going to be 11. Does 16 go into 11? No, it doesn't. Does it go into 112? Yes, it does. How many times? I think it's exactly 7 times, right? Yeah, so obviously we're going to start out with a relatively straightforward one. So the correct answer is 67. This one here, remember the video dividing by decimals that we talked about? So let's go ahead and practice that. So we put the 75.85, and then we put the house, and then we put 8. Because 8 is already an integer, we don't have to worry about converting that into an integer, but we do have to put the decimal place right here, or the decimal point. Remember, that's what we do. Okay, does 8 go into 7? No. Does it go into 75? Yes, it does. How many times? 9 times. 9 times 8 is 72. 75 minus 72 is 3. Does 8 go into 3? No. Bring down the 8. Does it go into 38? Yes, it does. How many times? 4 times. 4 times 8 is 32. And then 6, 38 minus 32. Does 8 go in? No. Bring down the 5. Does it go into 65? Yes, it does. How many times? 8 times. 8 times 8 is 64. 65 minus 64 is 1. Now we need to bring down a 0. So let's stretch this out a little bit. Does it go into 10? Yes, it goes in 1 time. 1 times 8 is going to be 8. And that's 2. 10 minus 8. And then again, bring down another 0. Does 8 go into 20? Yes, it does. How many times? It goes in twice. So we get 2 times 8, which is going to be 16. And then the difference is 4. I'm going to put the difference right there. Does 8 go into 4? No, it doesn't. We need one more 0, and it goes in 5 times. So what we get is 9.4812. Let me confirm that with a calculator just to make sure. We did it. Nice. All right, so this one here, we have a problem, right? Because if we are going to put our number in the house, so 10.465, and then we have 2.3. The problem is this has to be an integer. So what we need to do is move the decimal 1 to the right, but we also need to move this 1 to the right. So really what this problem becomes is the number in the house becomes 104.65 because we moved the decimal 1 to the right, and this becomes 23. And now we can just move the decimal right there. And we will get the right answer by doing this. So does 23 go into 1 or 10? No, but it does go into 104. How many times? I believe 4 times. Because 4 times 23 is going to be 92. The difference between 104 and 92 is 12. Does 23 go into 12? No, so bring down the 6. How many times does it go into that? I believe the answer is 5 times. Because 5 times 23 is going to be 115. And then here we get 11, the difference. And then if you bring down the 5, oh, we just calculated that, remember? We just said it, so that goes in exactly 5 times, and we're done. So we get 4.55. So remember, on problems like these, when you're dividing by a decimal, you want to convert it into an integer, but in so doing, you're also going to have to move the decimal point in the number in the house as well. So this one is testing our ability to determine what happens when we multiply by 10. Remember when we multiply by 10, it just moves the decimal place 1 to the right. That's all it does. So here if we have 4.72, and we can put as many zeros as we want here, right? I mean, we could put an infinite number if we want to. We usually just cut them off because it would be crazy. So here, how many times are we moving to the right? So once, twice, 3, 4 times. So once, twice, 3 times, 4 times. And we just put the decimal right there. And what we're left with is 47200, which is 47,200. So the correct answer is going to be D. Number 13, what is the result when you divide 0.3 by 10 and then divide by 10 again, and then again for a total of 6 times? So in this case, what's happening is we're moving the decimal point to the left because we're dividing by 10. So here we can do 1, 2, 3, 4, 5, 6, 7, 8. We can just imagine as many zeros as we want there. So 0.3. So we have to move it to the left 6 times. So 1, 2, 3, 4, 5, and then 6. So this is where the decimal place goes. Right there. So what we have is how many zeros? 1, 2, 3, 4, 5, 6. 6 zeros. 1, 2, 3, 4, 5, 6, and then the 3. So let's see. This is not it. That is 5 zeros. That is 6. 1, 2, 3, 4. Yeah, so it's going to be C. Last question. Recall the quick tip dividing by 5 video. So remember what that was? Like, for example, if you're doing 230 divided by 5. Okay, so the tip is the decimal place is originally here, right? So just move it 1 in, so you get 23, and then just multiply that by 2, and you get 46. So this question's asking us, does it work with rational numbers that are not divisible by 5? Interesting question. So let's take, for example, the number 8. Is 8 divisible by 5? No, it is not. But let's see if we can apply the technique. So we know the decimal point is right here. So the first thing we want to do, so step number 1, is move the decimal place 1 to the left. So now we have 0.8. Step number 2 is we multiply by 2. And what do we get? We get 1.6. So does 8 divided by 5 equal 1.6? The answer is yes, it does. Yeah, so this always works. And feel free to create your own example. But yeah, it always works. Cool. All right, I hope everybody enjoyed that. Have a wonderful day. Really quickly, I just want to add something here. So we gave an example of an integer. And so in theory, we could mark C, right? It will work as long as the number is an integer and fail otherwise. So let's actually try something that's not an integer. Let's try, for example, 1.4 divided by 5. So 1.4 is obviously not an integer. So remember the rule, the first step is slide the decimal place 1 to the left, the decimal point. So now we have 0.14. And the second step is to multiply by 2 and we get 0.28. So 1.4 divided by 5, does it equal 0.28? Indeed it does. You can use a calculator if you want to confirm it, although I would encourage you to do it on paper or in your head, because remember, on the quantitative reasoning section of the GMAT, no calculators allowed.